Hello and welcome to the Quatrefoil's staff seminar on dampness in buildings. We'll be looking at the potential sources of dampness to assist surveyors in the identification of problems so as to enable a solution to be found. This is a series of lectures and there will be an opportunity to ask questions at the end or by email if you're watching remotely. The principal causes of water ingress can be seen to be related in some way to the following. Firstly, external water ingress from rain or groundwater. Secondly, internal plumbing leaks from the subject or adjoining premises. And finally, the dreaded condensation. We do appreciate that the above could be split into an almost never-ending subcategory of headings. So let's split these up ourselves and look at each of the three areas. Firstly, external water ingress. This can be broadly split into rain and groundwater, along with water ingress from services such as leaking pipes. Rainwater can clearly soak in through the structure downwards, say through a leaking roof, or laterally through defective pointing and rainwater goods. It can also rise up through groundwater as rising damp or floodwater. So let's work from the top of the building downwards and initially look at roofing defects. It's important when checking a roof to look carefully at the surface materials, for example the tiles, slate, felt, etc., to see if there are any missing or broken tiles. Pay particular attention to the pitch of the roof, as certain tiles have to be laid to a minimum pitch and lap, or rainwater will drive up beneath them even if they're present. Check the lead or zinc work at the abutments and any flashings and soakers, as these can thin with age, weather, or even be robbed away. The roof in this image has dropped significantly, opening up a large gap for water to gain entry. What sort of defects would you expect internally as a result of this? Why has the roof dropped in this way, and how should you carry out repairs? Is there a risk of rot to the internal Bressumer timbers? In the next slide we'll be looking at defective rain and wastewater goods. One of the most common sources of water ingress into a property are from rainwater goods. A faulty gutter or downpipe can lead to water being channeled against the same area of a wall constantly, which causes it to saturate. This is a particular problem with earlier solid brick walls with no cavity. On inspection, check to the rear of old cast iron, soil and rainwater pipes, as these can corrode and split out of view. The problem can often be seen by staining on the face of the wall, which in the summer can look like white salt stains. On the adjacent photographs you can see a totally blocked gutter. I would imagine the downpipe is also full of moss, which will cause water to run down the face of the building. What is the defect in the second photograph? In the next slide we'll have a look at a report produced on site about this for a client.
One of the principal causes of water penetration into a building is defective rainwater goods, gutters and leaking roofs. You can see here there is a leaking gutter at high level falling onto the roof that's produced a lovely growth of buddleia and other vegetation, and the wall is also saturated running down its line, which is almost certain to have caused problems internally. In another location on the same building, again leaking and defective rainwater gutters have run down and caused significant damp down at the bottom of the structure here. As you can see, the joints are all very washed out. Brickwork has got extensive moss, so we'll be having a look inside behind this location to determine if there's any evidence of rot.
Corbel guttering. A particular detail to look out for on older Victorian properties is the OG profile gutter on a brick corbel, as shown in the photograph on the left. The rainwater goods here are often laid flat and should be on a suitable lead flashing or other waterproofing, although this is often not present. These will invariably leak over the years at the joints, and they can also corrode to the back, as they're never painted once they're installed. Any water escaping will just soak into the wall on which the gutter sits. At least an overhanging gutter, as you see on modern buildings, when they leak, the water should drip clear of the wall. If replacing these, we've shown a quick sketch on the right hand side of the preferred detail. Moving on now to flat roofs. Years ago, flat roofs used to only have a life expectancy of about 10 years. The old mineral 747 type felts tended to degrade with sunlight and split, particularly at the abutments where the felt was run vertically and had less support. Modern felts are a vast improvement, as are some of the single ply membranes out there, but there are still plenty of old flat roofs, and indeed roofs with modern felt materials that have been poorly detailed. When on site, closely inspect the edges in particular of any flat roofs, as these are where most tears and splits occur. In asphalt, keep an eye out for bubbles in the surface. Inspect the laps on felt and the direction in which they are laid, as this is also important. Check the fall of the roof and ensure that outlets, especially if they're internal, are clear of debris such as moss and leaves. Damage from foot traffic and barbecue coals is not uncommon, so keep an eye out for that disposable barbecue. On the photographs here you can see some fairly obvious defects on flat roofs. Although they're not causing any problems internally, at the present time there's no damp staining getting in, it's only a matter of time, and by the time that the damp does start to manifest itself, you're likely to have issues with rot in the timber, particularly on the decking on the left hand side and in any of the joists on the right hand side roof. I couldn't resist this particular photograph. This came up on an inspection in Bowes Road. This is a residential flat above a shop premises below. What's happened over the years is people have thrown all their debris out of the flats and just dumped it on the roof which goes over the shop, and this has just completely blocked up the outlet which is to the right hand side of this property. This has caused horrendous damage in the shop premises below. The ceilings are collapsing, water is pouring in, and yet nobody has bothered to go up on the flat roof and pull the plastic bag out of the outlet. So some minor repair works or maintenance at an early date can stop quite significant problems occurring at a later date. A superb resource that I can't speak highly enough of is the building research establishment defect action sheets that look at defects that buildings suffer and then show you the various cause and remedies. Here you can see defect action sheet 34, which looks exactly at what we were talking about, splits in the felted material at abutments, and also here it's looking at the positioning of any cavity trays. Now these are out of print at the moment, but you can still find them if you look around on eBay.